All right, so now that we have established how to evaluate expressions based on the hierarchy of the powerfulness of mathematical operations, let's talk a bit about expressions that have symbols in them. So things like A, B, C, X, Y, some of the more common letters or symbols that we see in mathematical expressions and then later in equations and functions. So let's take a look at a couple examples. So as a foundation for this, I want to just kind of talk about how we define things like 3x, for example. So let's put right here 3x. So 3x obviously means 3 times x, but more specifically it means x plus x plus x. Basically, 3x means we have 3, 1, 2, 3 x's. So that's probably, again, not rocket science, but it's important that we think about the actual meaning behind these expressions if we're going to know how to combine and simplify them. So another example, let's say we had 5x. That would be the same as saying we have 5 x's. So that would be x plus x plus x plus x plus x. So those are 5 x's. In contrast to this, let's think about what it means if I were to have, let's say, x times x times x. So instead of addition, we have multiplication. In that case, x times x is simplified to x cubed. In other words, we have x being multiplied by itself 3 times. And similarly, if I wanted to know what x to the 5th would be, that would be x times x times x times x times x. Now, why is this important? Well, I would say the reason that how we define things like 3x versus x cubed or 5x versus x to the 5th, the reason that is so important is because it helps us understand how to combine like terms and how to avoid making mistakes in algebra. So, for instance, if I had an expression that looked like this, let's say 3x plus 5x. You may remember that we can actually simplify that. Basically, simplifying it just means we can write it a little bit more easily by saying that we have 8x. 3x plus 5x equals 8x. Now, just in case there's any of us here who are like, okay, that's great, but why? Like, why does 3x and 5x become 8x? The reason is because, remember we said that 3x is really just x plus x plus x, right? And we said 5x is really x plus x plus x plus x plus x 5 times. So if I take 3 x's and I add to that 5 x's, we have 8 x's. That would be my son screaming for fun in the background. Don't worry, nobody is dying right now. That's a happy scream. All right, so 3x plus 5x equals 8x. However, let's suppose that I had something like 3x plus, let's say, x squared. Actually, you know what I'm going to do? Well, yeah, I'm going to put a 2 just to make it a little bit easier to see here. So a lot of times when we have something like this, a common mistake that somebody would make is they would say, oh, 3x plus 2x squared. Well, that's like, I see a 3x and a 2x, so I'm going to make that 5x. And then sometimes we just then throw on the squared at the end. And I would say, uh-oh, that is a problem. Don't do that. So you might say, well, why not? I'm going to take that off. Why not? In math classes, we usually use the term, these are not like terms. And what we mean by that is we have an x and we have an x squared here. And we say we can't combine them together because they're not like terms. Well, maybe you ask, well, why not? Like, what makes x and x squared so different? And the reason that they're so different is because of how we define them. 3x, we said, would be like x plus x plus x. 2x squared would be x squared plus x squared. We have 2x squareds. So if I take 3 x's and 2 x squareds, can I like put them together? No. We have x's, we have x squareds, and x is like a one-dimensional object, and x squared is a two-dimensional object. Totally different mathematical objects right here. So we can't combine a 3x and a 2x squared because of how we define it. So keeping that in mind,